Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the moment of inertia of hollow sections, and we are going to solve the problems on them. Let us begin here. In this section here, the figure shows a cross section of a caster and beam. We have to find out the moment of inertia of the section about horizontal and vertical axis passing through the centroid of the section. The section is having, how it is a hollow section, it's called as, because the total combination is a rectangular section. In that, if we subtract the semicircle portion, if we combine both, it becomes a circle. Two half circles, if you subtract from this rectangular section, we will get this type of section. Okay, this the section will be obtained. So we have to find out for this type of sections, find out the moment of inertia for this type of sections. How to find out? Now here, when two semicircles are placed together, it will form a circular hole with 50 millimeters diameter. The 50 millimeters radius this side and this side is 50 millimeters. Then it becomes 100 millimeters diameter. So we have to find out here the moment of inertia of the section about the horizontal axis passing through the centroid of the section. That is our objective. For that, the circle is subtracted from a rectangle. In overall view, in comprehensive view, if we understand this section, there is a rectangular section. In the rectangular section, if you subtract the circular, then you will get this section, this geometry. How is subtracted? The semicircular portion, from the semicircular portion, instead of here, you subtracted from this end, this portion and this portion. Then the portion here is, this is the portion of the given section. How to find out? This is the portion. We have to find out the moment of inertia. So these two halves, if you combine the join here, it becomes a circle. Then if you subtract the circle from the rectangular section, you'll get it. The moment of inertia of the section passing through the centroid of the horizontal axis passing through the centroid of the section. Now, this section is symmetrical about horizontal axis and vertical axis. That's why it is a two lines of symmetrical section. It is the symmetric about horizontal and also symmetrical about vertical. It is the two axes of symmetrical section. First, where it will be located, the moment location of the centroid. The centroid is the centroid will here 25 plus 100 by 2. It is at a distance of 75 millimeters. What about here from this section? What is the distance? That is 120 by 2. That is 60 millimeters. The centroid is located as 60, 75. The bar x equal to 60 millimeters and bar y equal to 75 millimeters. Directly we can locate without substitution in the expressions of bar x and bar y. So bar x equal to a1 x1 plus a2 x2 by a1 plus a2. And bar y equal to a1 y1 plus a2 y2 by a1 plus a2, provided for solid sections. But here, the bar x is for this hollow section, that is a1 x1 minus a2 x2 by a1 minus a2. The bar y equal to a1 y1 minus a2 y2 by a1 minus a2. Now, here the point is that it is passing through the directly centroid. It is symmetrical about both the axes of symmetry. For those sections, how to find out the moment of inertia? The moment of inertia can be found by, what is the moment of inertia for hollow section? Here is there's two axes of symmetry. Then by applying the parallel axis theorem, what will happen here? The parallel axis theorem, Ixx equal to Ig x1 plus A1 times H1 square. Now what about plus here minus of Ig x2 plus A2 times H2 square. Here in this section it is passing to two lines of symmetry, that means H1 equal to 0. So bar y and y1, bar y and y2 all are same for two lines of symmetry. Bar y equal to y1 equal to y2. Similarly bar x equal to x1 equal to x2. That means this term becomes 0. What will be left here? So Ixx equal to Igx1 minus Igx2. What is the Igx1? Parallel to x-axis. This here, the x1 means the total rectangle. The parallel to the horizontal axis, that is BD cube by 12. What is the B here? The breadth is 120 and D 100 plus 25 plus 25 150. That is 120 times 150 cube by 12. That is 33.75 times 10 power 6 millimeter power 4. That is Igx1. What about Igx2? Igx2 equal to, what about Igx2? We have to subtract the circular section. That is Igx2 means pi d power 4 by 64. What about pi? What is the d? Diameter. That is 100 millimeters dia. 100 millimeters power 4 by 64. Then it will be obtained as r pi d power 4 by 64 r. Here pi r power 4 by 4. But the value will be same. That is 4.91 times 10 power 6 millimeter power 4. That is Igx2. And Igx1. What is the Igx1 is? The Igx1 is 33.75 into 10 power 6 millimeter power 4. 33.75 into 10 power 6 millimeter power 4. Now Igx1 minus Igx2. That is 33.75 times 10 power 6 minus 4.91 into 10 power 6. You have to subtract. Then it becomes 28.84 into 10 power 6 millimeter power 4. That is Ixx. It is the passing through the centroidal section parallel to horizontal axis. That was the object. First object is over. This is horizontal. Now what about next? Vertical. The vertical axis can be calculated. How it can be calculated? About the vertical axis. Then Iyy1. That is Iyy equal to. What is Iyy equal to? Iyy1 section 1 minus Iyy2. What about Iyy1? That is first section 1 is rectangle. That is a section 1. Section 2 is half semicircle. That is circles. Iyy1 is D1 B1 cube by 12. What about D1? Depth is 150 millimeters. B1. What about B1 here? The B1 is 120 cube by 12. Calculate this value. Iyy2. What is the Iyy2? Semicircle. That is pi d power 4 by 64. Pi into what is the diameter here? 100 millimeters power 4 by 64. Subtract Iyy1. Subtract this Iyy2 from the value of Iyy1. Then it will obtain as Iyy. That is the vertical axis passing through the centroid of the section. The next portion is the part 2. Vertical axis. That is a db cube by 12, 150 times 150, that is the d. What is the b here? 120. This is a d1 total and it is a b1. That is 150 times 120 cube by 12, that is 21.6 into 10 power 6 millimeter per 4. The next one is area of the semicircular, one semicircular area of the no, not required. This is the portion. Then what will happen? It is symmetrical about, yes, you can subtract the method of that circle also, you will get it directly. Then how much we got here? Ig2. Now this is the semicircular portion, yes. Okay, then how to get it? That is pi d power 4 by 64. You can subtract that portion also, total portion, that is I by y. But still, what is the value? We got it here, the moment of inertia. That is 13.2, 2 times. The method they used here in this section is another method of the area of one semicircle section, that is pi r square by 2. that is pi into 50 square by 2, that is 3927 millimeter square. Now IZ2, we know that IZ2 of each section, that is 0.11 times r power 4, 0.11 times, what is the r radius here, 50, that is 50 millimeters. Substitute here, that is 0.11 times 50 power 4, 687.5 into 10 cube millimeter power 4. Now the distance between the center of gravity of the semicircular and its base, okay, semicircular and its base, that is 4r by 3 pi, 4 into r, 50 by 3 pi, that is 21.2 millimeters. Now the distance between the center of gravity of the semicircular section and its axis, that is vertical axis, that is 60 minus 21.2, that is 38.8, because it is the total is 60. From this, it is 4r by 3 pi. If you subtract from here to here, it is 4r by 3 pi. 60 minus 4r by 3 pi, this distance will be obtained. That is 38.82. That is Ig2 plus A2H2 square. Then substitute here, then you get it 6.6 into 10 power 6 millimeter per 4. That is for one semicircular section. So there are two semicircular sections, so 2 times 6.6 into 10 power 6. That is 13.2 10 power 6 millimeter per 4. Now, we know the centroid of the whole rectangular section, that is db cube by 12, that is 21.6 into 10 power 6 millimeter per 4, minus this 13.2, that is 8.4 into 10 power 6 millimeter per 4. Alright. Now, the point is that here they consider that method. Now, what will happen here? That is db cube by 12 minus the circular section if you subtract. That is another, is the two half circles. For the method which you explained before, it is passing through the center of gravity. For circular, both horizontal and vertical, it is remains the same. That is pi d power 4 by 64. If you subtract that way, that is directly comes. Alright. Now, find the moment of inertia of a hollow section shown in figure about an axis passing through its center of gravity or parallel to x-axis axis, parallel to x-axis. So parallel to x-axis means passing through, it's symmetrical about vertical axis. So we have to find out the bar y here. After finding out the bar y by using the parallel axis theorem, we have to find out the center of gravity. We have to find out the moment of inertia about an axis passing through its center of gravity or parallel to its x-axis axis. Now, the width of the section is 200 millimeters. It is 300 millimeters. And the circle is 150 millimeters. It is at the distance of, what is the distance of the center? The center is at a distance of 100 millimeters from the top face of this rectangular section. Now, there are two sections we consider. It is symmetrical about vertical y axis. But what to be found, as I told you, A1 bar y equal to, for this hollow section, A1 y1 minus A2 y2 by A1 minus A2. What is the rectangular section? Here, the rectangle, we have to locate the center of gravity. We know one axis. We need another axis, horizontal axis. How to find out that horizontal axis, centroidal axis? It is at a distance of bar y. That's why that bar y is going to be calculated now. Now A1 y1 minus A2 y2 by A1 minus A2. That is A1, that is 300 times 200. That is area of the section. This is the total rectangular section minus circular section. Now what about y1? That is 300 by 2, 150 millimeters. Now circular hole A2, pi d square by 4, pi times d, 150 millimeters square by 4. That is 17670 square millimeters. Now what about y2? Y2 is at a distance. This is the center from this reference axis. How to locate this y2? This is the y2 distance. How to find out this y2? You cannot say 300 by 2. No. Now what is the distance from here to here? 100 millimeters. Now 300 minus 100. Total, this 300 minus 100, that becomes y2. So that is y2 is 300 minus 100, that is 200 millimeters. Okay. Now we know the values a1, y1, a2, y2. If you substitute in the derived expression of bar y, that is a1, y1 minus a2, y2 by a1 minus a2, then the obtained value of the bar Y is 129.1 millimeters. So the bar Y is at a distance of, it is at a distance of where we don't know the exactly, this 300 by 2, 150. So it is around 129.1 millimeters. 129.1 millimeter. And it is symmetrical about which axis? Vertical axis. This is the CG, center of gravity of this hollow section. Now we have to find out the moment of inertia about this horizontal axis, about x-axis. How to find out about x-axis? Let us begin. Iz1 equal to Iz1. That is, there are two sections are there. One is rectangular section. Parallel axis theorem we use from the expression. Subtract that one. So from that we have to subtract of a circular section's moment of inertia, or we have to subtract from rectangular section. So first rectangular section 1, that is Iz1 equal to B dq by 12. What is the B? 200, D 300 q by 12. That is 450 times 10 power 6 millimeter power 4. What about H1? Distance between two center of gravities. Center of gravity of the rectangular section to the total center of gravity of the total section. That is 150 minus 129.1. That is 20.9 millimeters. Now moment of inertia of this rectangular section about x-axis is Ig1 plus AH square. Ig1 is 450 times 10 power 6. What about area? 300 into 200, and H, that is 20.9 square millimeter square, H value. Then it becomes 476.21 into 10 power 6 millimeter power 4. That is for Ixx1, that is section 1. Now moment of inertia of the circular section about an axis through its center of gravity and parallel to x axis, that is required. Okay, how to find out here? That is Iz2 equal to what is the Iz2? Pi d power 4 by 64. What is the diameter here? 150 power 4 by 64. That is 24.85 into 10 power 6. Now what about H2? Distance between the center of gravity of the section and its x axis. Very, very important here. This H2 is the distance between the center of gravity of the circular section and its x axis. This x axis is at a distance of 129.1 millimeters. What about center of gravity of the section? From here, what is this distance? That is, distance is how much? 300 minus 100, that is 200 millimeters. We want this portion. This is x-axis. This is the center of gravity y2. So y2 minus y bar, 200 minus 129.1, then you will get the distance, that is h2. That is what we did. 200 minus 129.1 millimeters, that is 70.9 millimeters. Now we know the parallel axis theorem. That is Ixx2 equal to Iz2 plus AH square. That is, what is Iz2 here? That is 24.85 times 10 power 6. What is area? Pi d power 4 by 64. Whatever H2, 70.9 whole square. This is 113.67 into 10 power 6 millimeter power 4. Ixx2. Now we have to subtract this Ixx2 from Ixx1. That's what we did here. Then we'll get it Ixx. What is about Ixx1? That is 476.21 into 10 power 6. Ixx2 is 113.67 into 10 power 6. 10 power 6 make it common and subtract this 113.67 from 476.21 value. Then it is 362.54 times 10 power 6, that is millimeter power 4. This is the axis, moment of inertia of the whole section about x axis. That is what they asked about an axis passing through its center of gravity or parallel to x axis. That is what we calculated now for this, the calculation of this moment of inertia of this whole section. Okay, coming to the third problem of the hollow section is the triangular. From that we have to subtract the rectangular section. Then we'll get it the hollow triangular section. This is hollow, this is the section. Now a rectangular hole is made in a triangular section as shown in figure. Determine the moment of inertia of this section about an axis x-axis passing through its center of gravity, and the base is BC. So these complete dimensions were given here. The width and height, depth of this rectangular section. The base is 100 millimeters. This is 20 millimeters for rectangular section, and height is 30 millimeters. How to begin here? So triangular section, the base is the BC. Let y is the distance of center of gravity of the section, and the base BC. Now A1 triangular section, that A1 equal to section 1 triangular, that is half base times height, half into 100 into 90, that is 4,500 square millimeter. Now Y1 equal to, what is the Y1? That is H by 3, 90 by 3, 30 millimeters. Now rectangular hole, what is the rectangular hole? A2, that is 20 thickness and height 30. 30 minus 30 times 20, 600 square millimeter. What about Y2? The Y2 distance from the center of here. How it comes this distance? This distance is this plus this. What about this distance? 30 plus 30 by 2. 30 plus 30 by 2. That is 45 millimeters is Y2. Now, what is the center of gravity? Yeah, the center of gravity is bar y equal to A1 Y1 minus A2 Y2 by A1 minus A2. A1 Y1 4,500 times 30 minus A2 Y2 600 times 45 by A1 minus A2 4,500 minus 600. That is 27.7 millimeters. Now, after knowing this bar y, we got the location of the horizontal axis from the base. It is how much value? 27.7 millimeter. Here to here, 30. 27.7 millimeters. Here it is a bar y. That is 27.7. Now, we want moment of inertia of this triangular section through its center of gravity and parallel to x-axis. First triangular section, then we have to go for rectangular section, and you have to subtract the rectangular section from triangular section. Then you obtain the hollow section width of this whole section. Now IZ1, that is BDQ by 12. What is the BDQ by 36? That is BDQ, what is the base? 100. D depth is 90. That is 190, 100 times 90 cube by 36. That is 20, 25 times 10 cube millimeter per 4. What about H1? H1 equal to 30 minus 27. H1 is the distance between the center of gravity of the triangular section 1 to the horizontal axis XX. Now 30 minus 27.7, that is 2.3 millimeters. Now IZ1, IXX1, section 1 is IZ1 plus A2, A1 H1 square. That is 20, 25 times 10 cube plus 4,500 times 2.3 square H1. Then 2048.8 10 cube millimeter power 4. Now IZ2. What about IZ2? For rectangular section, that is BDQ by 12. What is the base? 20. D depth 30. 20 times 30 cube by 12. That is 45 times 10 cube millimeter power 4. What is H2? 45 minus 27.7, that is 17.3. This is the H2 is the distance between. Yeah, what is the distance between? That is 27.7 millimeters. Okay, what about this distance? That is 30 plus 15. This is 45. The distance, this gap comes 45 minus 27.7, that is 17.3 millimeters. Am I right? Here, what about bar y? That is 27.7. 45 minus 27.7, that is 17.3 millimeters. Now moment of inertia of the rectangular section about the x-axis, that is Ig2 plus A2 times H2 square. By using parallel axis theorem, that is 45 times 10 cube plus A2 600 and H2 17.3 square. Then the value is obtained as 224.6 into 10 cube millimeter power 4. Now we have to subtract this IXX2 from IXX1. Then the IXX, that is the moment of inertia IXX equal to, if you subtract, then 1824.2 10 cube millimeter per 4. Now that is the moment of inertia of the section about axis XX. Now The second objective, second part is that we also want, yes, we have to calculate that moment of inertia of the section about the base. We want about the base. About the base, Ig1 equal to BD cube by 12, then 100 times 90 cube by 12, that is 6075 times 10 cube millimeter per 4. Ig2 equal BD cube by 12, that is also, but that is 20 times 10 cube by 12, that is 45 into 10 cube mm per 4. What about H2? H2 means again, because we want this section about this, okay, that value is required, that is H2 equal to 30 plus 30 by 2, 45 millimeters. Now what is Ixx2? Ixx2 equal to Ig2 plus A2 H2 square. This H2 becomes 45, A2, that is 30 times 20. Now 1260 into 10 cube millimeter per 4. Now moment of inertia of the whole section about the base equal to the rectangular triangular section minus the rectangular section. That is 6075 times 10 cube minus 1260 into 10 cube. Make it common. 6075 minus 1260 times 10 cube. That is, if you subtract 1260 from 6075, then it becomes 4815 into 10 cube millimeter per 4. That is the moment of inertia of the whole section about the base BC. Now there are two things were asked here. The two things were here. One is the moment of inertia of the section about XX axis passing through its center of gravity. This one. And the second portion is that on the base, moment of inertia of the section about the base. This is, one is about its center of gravity. There are two parts are there, two objectives. One is about the base, another one is about the center of gravity. That's why to find out about the center of gravity, we have to find out the center of gravity, location of the center of gravity. For that, it is symmetrical about y-axis, vertical axis, but for that we need another axis, that is horizontal. The location of the horizontal axis comes from bar y. So the bar y we calculated here. The bar y using the bar y equal to a1 y1 minus a2 y2 by a1 minus a2. Okay, and bar x, what is the bar x value of this value? What is bar x value? This distance, if you take it the vertical distance, that is 100 by 2, 50 millimeters. So the bar x is already here. We consider this is the bar x here. What is the bar x value here? If you consider this is the reference axis, it is 50. It is symmetrical about vertical axis. Why? The bar x for this section we are already considering this is the reference. That's why bar x equal to 0. Based on consideration of the reference axis, we'll get bar x and bar y. All right. Now how we found this bar y value? By substituting in this expression, that is a1 y1 minus a2 y2 by a1 minus a2, we'll get the bar y value. All right. Now after that, what we did here now in this section, in this problem, the two objectives were asked. One objective was about the axis passing through center of gravity, another one about its base. That's why we calculated two parts. That is the part 2, that is moment of inertia of the section about the base. You might have got doubt here, this Ig1 BD cube by 12, why it is directly given about the base. Okay, if you want to apply the parallel axis theory about the base, that is, yes, Ixx1 equal to Ig1, that is Ig1 plus area A1 H1 square. Now what is the Ig1 here? The Ig1, what is the Ig1? That is BD cube by 36. That is BD cube by 36. If you do it, that is BD cube by 36 area of BD. Okay, what about H1? H1 is the distance. What about H1? Distance from center of gravity through this. Center of gravity, that is d by 3 whole square. Now, if you make it BD cube by 36 plus BD cube by 18, then we will get it as BD cube by 12 only directly. This value unit will come. That is about its base. Okay. BD cube by 36, BD cube by 8. Yes, 1.5. That is 3 by 2. 3 times 12. Yes, BD cube by 12 it comes. Now, so far in this section we covered, there are three problems solved, 3 hollow section, moment of inertia of 3 hollow sections calculated. The first hollow section is a section, that means rectangular section minus circle, such as it is symmetrical, 2 lines of symmetrical section. The second hollow section is 1 line of symmetry, and the third hollow section is also 1 line of symmetry. That is a triangle, and first 2 problems are rectangular sections, and the third problem is a hollow triangular section. Okay, rectangular hole is made in a triangular section. So there are many things we can solve, not only these problems, triangular section, rectangular section. We can also solve, suppose if there is a rectangular section, in that if you subtract another 2 rectangles, then it is obtained the I section, I section will be obtained. This is the I section. The hatched portion is the H section. So it is a rectangular portion. From that, if you subtract 2 rectangles, the total rectangular portion is the 1. From that, 2 and 3. Yes, then we'll get it. The rectangle portion 1. From that, the portions, this is 1 portion, and these 2 portions, if you subtract, so 1 minus 2 minus 3. Okay, then we'll get it, the total portion of I section. There is a parallel to x-axis, means IXX. What about 1? The 1 is the rectangular section, that is IXX of R rectangle, minus 2 IXX2, that is 1 rectangle, second rectangle, minus IXX3 of third rectangle. Thus it will be obtained about the total inertia. That is one of the method, the shortest method if you want to do it, because it is a 2 lines of symmetry. For the 2 lines of symmetry, if you apply the parallel axis theorem, H1 equal to 0, H2 equal to 0, and H3 becomes also 0. Then finally what will happen here? B1 D1 cube by 12 minus B2 D2 cube, if it is B2 and it is D2 and it is B3 and here it is a D3. B2 D2 cube by 12 minus B3 D3 cube by 12. That is IXX of the whole section. B1 D1 cube. What is the D1 here? That is the D1. This is B1. So if you subtract here, we'll get it directly. The moment of inertia of the section, the hollow section passing through the center of gravity parallel to horizontal axis. Okay. In that manner, we can calculate the various sections moment of inertia, the moment of inertia of the various sections by considering as a hollow section method, by considering it as a hollow section or a solid section. But mainly we use it here parallel axis theorem for solving all the problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.